a truck in here that has a GM Vortec 2.4 engine. It's a Hyster S70 FT. It was brought into the shop. Um, Basically, it's not starting. Complaint was it's misfiring, and what was said from the tech was that it is possibly a timing issue. All right, so mechanical timing is basically what they were doubting. Okay, so let me crank it for you. So okay, it's not gonna start up. I disconnected the injectors because I don't want this. I don't want to hear the loud bang. But just from the sound of the cranking, I would not doubt right away the timing on this mechanical timing because it cranks even. All right, so let's go with the simple first. All right, let's check for ignition. So this is a waste spark system. So basically number 2 and number 3 comes from the same coil, fires at the same time. So we got our test light that's connected to the negative. All right, I'm gonna put it right here. See if we can see the spark jump by cranking. There's nothing. It's actually deep. Let's see. Try one more time. Okay, there is a spark. Okay, that's on the number 3. Okay, let's put this back on. Let's check on the other coil. So this is gonna be the number 1 and number 4. Try to do it here. See inside if we see a spark. Okay, so no spark there. Put in a little bit in and see if we can see that. Okay, so no spark whatsoever on that coil. It's more likely than not because this is the same coil. We can actually test it out still. Let's see. See if we get something on the number 1. All right. See if you can see that in there. Okay, nothing in there as expected. And so because there's firing in one coil, what I'm gonna go for next is a signal wire. I'm gonna have to check. I know the power is there. I know the negative is there. They have the common positive. They have the common negative. We're gonna check the signal, which is these two, for the individual coils. So I got my channel A and B on the signal wires for the coil, come from the computer. And just for reference, I have my amp probe connected to the battery positive towards the starter. All right, so starter is gonna be the green trace. Of course, the red and the blue is going to be my signal from the computer to that coil. All right, let's crank it up. See what we get. Okay, I'm going to have to increase the time base. I might not be able to see anything here. Increase the time base to maybe 1 second per division. Cranking. Okay, let's pause that. See what we got. Stop the capture. All right, go back. I'm gonna be looking at this part right here. This is the capture we got. So the red and the blue trace is gonna be the signal from the computer to that coil, and the green trace is gonna be my amp clamp. So each and every hump is gonna be 1 cylinder going into top dead. And so you can see that the humps are pretty much fairly even, and you can see where the signal goes down is supposed to be when the coil should be firing. And that's pretty close to top dead, right? Even on the blue. So again, this is more to back up that this is not going to be a timing issue, or the cam and crank mechanical timing or ignition timing for that matter. At least not yet, because I'm fairly close to top dead. So At this point now, I'm going away really from this being ignition timing, timing issue, cam crank, or whatever it is. All right, so again, we got the signal to both coils, and they're almost right on the money. And so, being that we don't have any spark coming out of the one side of that, I'm gonna be replacing this coil now and see what we get out of this. So I'm pretty much sure we need a coil, all right? But I just wanna take a look at the current going into those coils. So I got my amp probe now hooked up. It's gonna be on channel C, right? I still have my signal wires with the red and the blue trace. Let's try to crank it up. Okay. Okay, that's the problem. Let's try to pause this. In even went up higher than my setting up 10 amps. Let's try this again. I'm gonna increase it up to 20 amps and then we're gonna crank it again. All right, see what we're getting up to. So there you go. So that's gonna be enough for me. All right, so that is the waveform that we got. The green trace from earlier is gonna be my current. Blue and red is gonna be the signal coming from the ECM to the ignition coils, the coil pack, all right? And the one thing that's not normal is this shot up to like almost 9 amps, which is a bit high, but then again, it never went down to 0, right? And we're gonna try to explain this by using a diagram, and hopefully we can make sense of why this is happening. This is the waveform that we captured earlier. So the green trace is going to be the current consumption for both my coils. Um, the red trace is going to be the current ramp for my starter, and of course the blue and the gold trace is going to be my signal for each of those individual coils. Alright, so let's talk about this more in depth. Here's another capture. I just erased it. The blue trace now is hooked up to the supply voltage for the coil, and this sort of kind of explains why you have these humps here on the green trace. So the supply, because of the large current drop from the starter, also oscillates with the current draw. So the voltage supply to those coils, whenever you see this hump going up because of the large current drop from the starter, the voltage supply also drops, and thereby the current now also drops on that coil. But that is not the main concern here. The main concern is that at key on, which is right here, the current for that coil stayed at a little more than 10 amps right here. And each and every time this coil fires, that it has a signal, you see it shooting up to like almost 16, almost close to 17 amps. That is the problem right there. Now on the next slide, we're going to try to explain why this is happening, or at least why I think we're seeing this kind of a waveform. So this is the schematic of a simple schematic of what's inside that coil pack. Now there might be some more components here, but this is basically how it should work in there. So both these coils, both primary coils inside that pack, would have a common positive supply from here and also here. So at key on, they get the same positive. It's common to both of them. And of course, they also have the same negative. Now, I know this is not broken because I am getting a spark out of the number 3 and also out of the number 2. So I know this coil is working, and I know this coil has a base signal because it produces a spark. The problem is with the coil, the primary coil, or primary circuit for the cylinder number 1 and number 4. Now what I think is happening is this driver now inside this coil has already shorted, and this is the reason why I'm saying that it's shorted. If the coil was shorted, inside and the driver is not, there should only be current whenever a signal for the base of transistor A has been provided. But that is not what we see. What we see is every time that after key on, that voltage is already provided to both primary coils, you would already see a current draw of about 10 amps. That's constant. And that's what I'm saying, that this coil right here is not open, it's not shorted, or it may be, but it doesn't really matter. This coil is not open, but this driver is already shorted, and that's why you see the 10 amps or more than 10 amps, about 11 amps of current draw whenever the key is already on. It never drops down. Now let's talk about the spike that we see whenever the B is supplied with a signal. So I think this is what's happening, because remember that these coils are in parallel to each other, coming from a single supply. Our current probe is right here. This is where we have our current probe. Now, our current probe reads the current from both coils. When you key on, we see the current from A. That's already constantly 10 amps. And then, when B transistor gets a base signal, this also consumes current, which is now going to be added to A. So whenever B fires, we see the current here on the current clamp. The current from A is added to the current on B momentarily when the B transistor has been supplied a base signal. And that's what I think why we see the current waveform that we're seeing. So I hope that is a good enough explanation on why I think that the problem is inside the coil and that the driver is shorted, and why we are seeing the waveform that we are seeing as far as the current waveform is concerned. Right, so new coil. I also did the cables and the spark plugs. Looking at it, this is the other one that came out, so not looking really too good, so might as well replace that. The cables I had to replace anyway. I don't want to take the chance on that. If that coil is already broken, chances are it is the cable and the spark plugs that destroyed it. So okay, let's start it. Injector's already plugged in. There you go. Coil problem. Right, so I'm gonna get the readings out of this just for comparison, to compare with the other one, the broken one. Engine's running. I got my amp clamp hooked up to the positive supply for the coil, and I just got a sync probe. It's gonna be on one of the signal wires. So we're looking at this. So this is what I wanted to see from the get-go, the ramp up, and you see the signal. Whenever it goes up, that's when it ramps up, and when the signal goes down, that's when it saturates, goes down. That is supposed to be where the ignition is going to be happening. So the difference is, you see it's ramped up, down, and goes back to zero. The previous ones, on the one that was defective, it stays at a higher amperage all the time. It never goes down, right?